The second level of our odor management approach is to minimize the distance from where an odor source is to where that odor is being collected. So once we have odor on our hands, our goal is really to get this odorous air into an odor treatment system, which is going to remove or destroy that odor. And the best way to do that is to collect it as close as possible to where it's being created. That gives it the least chance of escaping out into the environment, and we'll also be collecting it in the highest concentrations, which are the most effective to treat. So the best way to collect odor is directly from the equipment. So a lot of waste processing equipment will have hookups directly on it that will allow you to pull the waste directly out of where the waste is being processed. This is kind of similar if you've ever done machining or woodwork to equipment that has a vacuum hookup for pulling off the chips or sawdust right on it, rather than having to come and sweep them up later. The next best thing is to have a hood or a shroud around the equipment, kind of like your stove fan in your kitchen. It's not right up against it, but it's pretty close, and it's going to pretty quickly catch everything that's coming off it. This you can resort to if your equipment has to be open or it's not built with that receptacle to hook your odor collection piping right into, but it's kind of the next best thing. And that's what's shown in the picture over here. This is for food production, but same kind of idea for a waste application. And then the last thing, the least effective thing, is to not really use a targeted approach, but just make sure there's enough general ventilation in that room to remove enough odor. This is kind of the case with a bathroom fan. We just have one big fan in the ceiling. Our next measure is to contain odors within the building. So we've got some odors going on. They've gotten out of our equipment. They're just in the air, but we want to make sure that they don't get further out into the environment. And one of the most effective ways to do this that's done in waste facilities is to maintain negative air pressure within the building. And what that does is any door or window that's open or any little crack in the building construction, the air will flow from out to in rather than in out and spread your odor. So maintaining negative pressure is a really good measure to kind of keep everything coming in rather than going out. The other thing that's done all under negative pressure is to use an appropriate air change rate in each room. So if you're a worker in a room where there's a lot of odor being produced, in order to be protected, you're going to need that air to be cleaned out with clean air at a higher rate than if you're in a room that has lower odor production. So there's in different codes, different air change rates specified for different types of uses of different rooms. And in order to really efficiently do this, what you do is you bring fresh air into your building, into its cleanest room. So in a waste facility, this might be its administrative areas, offices, change rooms, stuff like that. And then it will cycle from the cleanest rooms to progressively dirtier rooms. Because if you go to the dirtier room, then you can't go to the clean room later, right? You'll be exposed to that odor. So you keep going and moving the air from room to room, and then it will kind of, you can think of rinsing out the odor compounds from each room. And then when it gets to the last dirtiest room, then it will from there be taken either to odor treatment system, or it could be used as process air for the composting process, or aeration air for an incinerator, different things like that. But you basically have to do something with that really dirty air at the end. If you were to bring in fresh air to every single room, you would have better removal of the odors, but you'd have way more air to treat, which would increase your costs. You're also heating all this air, right? So it costs energy as well as the fans itself. So by doing this plan of routing the air from the cleanest to the dirtiest rooms, you do get that air change in each room, and you also do it in a really efficient way that keeps your utilities costs down. Another important aspect from the building design perspective is the doorways. So while you're maintaining your building under negative pressure under normal conditions, whenever the door opens, it's going to disrupt your negative pressure and it's going to start equalizing. So you want to prevent that pathway for odor to getting out as much as possible. One really easy way to do that is to use rapid deployment doors that go up and down really quickly, just to maintain as much pressure as possible as vehicles or people are accessing the buildings. In addition, you can also use air curtains, which have fans that direct the flow of air such that there can't be a net flow of air out of that doorway. These are also used, you might have seen them in stores, to keep warm air inside. They also can keep odor inside. In addition to these engineering approaches, you can also have policies that minimize the number of doors that are open at any one time or different times of the day, things like that. In the picture, this is from a transfer station, and you can see there's evidence of some policies. They've got red and green lights at each bay to determine when each door can be open and a little gate to help control that. So those are some ways that you can make sure you've got, all your doors closed as much as possible, and then when they are being operated, just having them move as quickly as possible, or using air curtains to provide some additional guard against that bulk airflow out of the building.